Another way to simplify a radical expression is to rationalize the denominator. You rewrite the expression so that there are no radicals in any denominator and no denominator in any radical. To rationalize a denominator, you want to eliminate the radical from the denominator. To do this, multiply the expression by 1, where 1 is written in a form that allows you to eliminate the radical from the denominator. Note the rational number 1 over the square root of 5. We have a radical in the denominator, and multiplying the square root of 5 by the square root of 5 will eliminate the radical. The square root of 5 times the square root of 5 is simply 5. However, since we don't want to change the value of the fraction, just the way it looks, we'll need to multiply by 1. But we get to write 1 however we like. In this case, we'll write 1 as the square root of 5 over the square root of 5. Now multiplying 1 over the square root of 5 times the square root of 5 over the square root of 5, we arrive at the square root of 5 over 5, a fraction with a rationalized denominator. Problem 5, rationalizing the denominator. This one's multiple choice. What is the simplest form of the cube root of the quotient 5x squared over 12y squared z? Well, first take note. We can rewrite the cube root of 5x squared over 12y squared z as the cube root of 5x squared over the cube root of 2 squared times 3 times y squared times z. Take note what we've done here. In addition to writing the cube root of the numerator over the cube root of the denominator, essentially distributing the cube root of the rational number both to the numerator and denominator, is we've started to rewrite the denominator in a way that helps us to establish perfect cubes and rationalize that denominator. 12 can be written as 4 times 3, and 4 is 2 squared. Now, we don't have a perfect cube yet, but we'll take care of that in the next step. So notice, the radicand in the denominator needs to be multiplied by 2 to get us 2 cubed, needs to be multiplied by 3 squared to get us 3 cubed, needs multiplied by y to get y cubed, and finally multiplied by z squared to get z cubed. That will make the factors perfect cubes. So we'll multiply this fraction by 1, but 1 written as the cube root of 2 times 3 squared times y times z squared over the cube root of 2 times 3 squared times y times z squared. And pay special attention to what happens in the denominator. The numerator becomes the cube root of 90x squared yz squared. The denominator becomes the cube root of 2 cubed, perfect cube, times 3 cubed, perfect cube, times y cubed, perfect cube, times z cubed, another perfect cube. So that's going to simplify very nicely. This becomes the cube root of 90x squared yz squared over 2 times 3yz. And then we simplify and get the cube root of 90x squared yz squared over 6yz. So the correct answer is A. Your turn, part A. What is the simplest form of the cube root of 7x over the cube root of 5y squared? And part B, a reasoning item. Which choice in problem 5 could be eliminated immediately? Explain your reasoning.